I want to start by thanking everyone for inviting me. Apologies for me doing some last-minute fine-tuning on my slides there. That's a disease that scientists have when they give these talks. Anyway, I'm really glad to be here, and I'm particularly pleased to have the opportunity to interact with people that are not scientists. Most of our work here in our presentations tends to be to colleagues, and so it's quite technical. So as I go through, I'll try to explain things both in lay terms and technical. I see here there's a problem with audio feedback here. I don't have no, I meant I can't hear anything, but so I'm fine to continue. I don't have any feedback as long as you're good. I'm just going to continue. Great. So sorry about that. So as I said, I'm going to go through and try to translate everything into lay language as I go through. But if there are any questions, please let me know. So I'm going to start with this clip, which is this. As you saw, this talk is about memory, and I find this clip quite useful to just illustrate what it is I'm interested in, what we're studying in my lab. This is a clip from the movie Ratatouille. Hopefully, many of you have seen it. I don't really need to set it up. I think it's pretty self-explanatory. Okay, so I won't give any spoilers there about the who actually made the Ratatouille. But as you can see, the diner was transported back in time, and there's a lot here going on that I think is helpful that I'll be referring back to in our talk. I'll just mention quickly that at various moments we see various aspects of the experience. So at this moment we see sort of the onset of a retrieval cue. In this case, it's a sensory cue or taste or whatever. And this actually triggers a whole series of a cascade of events. Some of those events are about a place, a location. Some are about a time in your life. But the part that I'm really interested in is the feeling. And so because the subjective sense, the subjective state, the feelings actually, we think, convey something over top of what we see from just the details. So how did we start with this? Well, back in the early 90s, when I joined the Rotman Research Institute, I was studying traumatic brain injury, and this is a story very similar to Adam's story from this morning. I encountered a patient who had a severe traumatic brain injury. He made a good recovery. He was in a coma, but he recovered. He by neurosurgical standards, did well, but it became evident that he had lost access to all memories, his identity basically from before the injury. So he had retrograde amnesia, and he had this is a map of the brain indicating these white matter pathways connecting different parts of the brain, connecting the temporal lobe to the frontal lobe. And this is a reconstructed T2 weighted image showing damage in this frontal projections of the uncinate fasciculus, which is a fiber, as I mentioned, carrying information from the temporal to the frontal lobes. So we hypothesized that he was unable to kind of trigger memories through a frontal temporal disconnection. Here's a little video just describing him. I hope this works okay. If not, let me know.
On first blush, Luigi's story may seem like an ordinary one. He played football in high school. A few years later, he got married, started a family, and began building a career in manufacturing technologies. But Luigi remembers none of this. The first 32 years of his personal history, every last bit of it is gone, vanished without a trace.
I didn't know who I was. I didn't know where I was. I had no past. It's almost like being born 93 out of 30 to a 32-year-old newborn.
Most cases of amnesia obscure the past, while also diminishing the brain's capacity to store and process new experiences. What makes Luigi's case so rare is that he has retained the ability to create new memories. This means that unlike many amnesiacs, he has the ability to live a normal life. But each and every day, Luigi faces profound questions about who he is and where he came from. Another extraordinary aspect of Luigi's form of amnesia is that it's left his fact-based memory intact, while his personal memories have been completely erased. In other words, he can remember how to play hockey, but not the hockey games he's played.
Okay, so it wouldn't be talking from Canada without a reference to hockey, and that was obviously a professionally made video by very talented filmmakers. So this was a case that was dramatic and it had an impact in terms of understanding as a single case study. But we knew clinically, those of us working in various syndromes knew that that a loss of episodic memory, and by episodic memory I mean loss of the specific details, as well as that subjective, the feelings I was talking about, is not limited to these kind of extreme cases that had occurred to varying degrees in other patient groups. And so this prompted us, and there were already tests for this, including Michael Kopelman's autobiographical interview, which is very good. Not very good, it's excellent. But we wanted another, there were several reasons, which I don't have time to go into, that prompted us to create a new test called the autobiographical interview. Our test is the autobiographical interview. Michael Kopelman's test is the autobiographical memory interview. One of the problems in our field is that we're terrible at naming things. So this has created, just including memory, episodic memory, and so on, have created incredible confusion, which I'll get to later. But in any case, try not to create more confusion with my own errors. So our test, the autobiographical interview, looks like this. So what's unique about our test is that we have a narrative. We're really asking people to tell stories in a naturalistic way. So here's a story. I used to play badminton with this girlfriend. I was very envious of her looks. We used to have lots of fun. However, one day we went from one building to another to get to the badminton court, and there was quite an expanse and wet and slippery, and she suddenly slipped and fell down, and it was all kinds of contortions and peculiar movements, and I was unable to hold back my laughter, and I hurt her feeling so badly that she wouldn't speak again. So what we did in our test, and Adam presented some data from his own group earlier this morning, we take that transcript, we audio record it, we have it transcribed, and then we segment the details into what we call internal details and external details. So internal details are defined as anything related to the event that's specific to the event, and external details is basically everything else. So this could be happenings, perceptual information, and so on. And external details are mostly semantic, factual information. So let me show you how this works. So here's the same protocol. So as we saw, she kind of sets the story with what we consider to be semantic information. Now some might say, well, this is episodic because it's from a time of her life, but by the criteria of the test, it cuts across multiple episodes. So we consider it to be external to the main event. So the main event is the part about going to the tennis court. The external would be sort of the setting the context, what I used to do, we had lots of fun, and so on. All these details are then coded in their various categories. She has an emotional state of being unable to hold back her laughter, and then finally she ends off with the semantic details. This is a normal protocol here that we would score. Now this test was initially published in 2002. It's had you never know what's going to kind of have staying power in this business, and this is one of the things that did. It's been used very widely. Here's some results from patient HM, Henry Mollison, the famous amnesic patient. This chart is sort of difficult to interpret, but these vertical lines indicate normal performance over 5 life periods. These are internal details. So for example, across 5 life periods, most people recall, say, 50 internal details and a few less external details in this particular protocol. This was work done by Sarah Steinvorth and Sue Corkin's lab. And HM here basically recalled no details across the time periods. The red dot is another patient. Now, interestingly enough, for some reason here, he recalled an event that he had never recalled before, or so they thought, in great detail, even more than control subjects. And so this was unexpected, and in fact, even made the cover of Sue Corkin's book, because this was about it was actually about a plane ride. It was about a plane ride, and so that ended up being on the cover of the book of Sue Corkin's fantastic book about HM. But what was key here is, of course, we presume, given that he had no medial temporal lobe hippocampus, severe brain damage, densely amnesic, that he didn't actually re-experience what it was like in the subjective sense. Now, we don't know that. They didn't ask that. But he certainly was able to produce details for that one event, even if he couldn't do so for other events. In any case, this test has proven to be quite, as I mentioned, quite useful, particularly in relation to medial temporal lobe and hippocampal function. So here's work from my lab done by Daniela Palumbo, who you'll hear more about in a minute, looking at the hippocampal subfield. So these are cellularly distinct subfields of the hippocampus deep in the medial temporal lobe of the brain that have supposedly distinct neurocomputational functions. And one of particular interest is the subfield known as CA23 and the dentate gyrus, which are involved in pattern separation. So we found that internal details was related to the volume of this subfield in healthy people. Carl Hodgetts at Cardiff looked at the Fornix, which you'll hear more about in a minute, which is a white matter pathway carrying information from the hippocampus out to the rest of the brain, and found that the integrity of the Fornix is also related to internal detail production, but not external or semantic details. So that's kind of background setting for how, where we were in the mid 2000s when I got contacted by this person, SM, who has gone public. Her name's Susie McKinnon, and she's the index case of SDAM. And she actually emailed me. Now, Endel Tulving, I'm sitting here in my office at the Rotman Research Institute. Endel, who's alive and well, he's 93, used to sit right over there behind me. But she emailed him because she said she was intimidated. She emailed me because she said she was too intimidated to email him directly. Anyway, here's what she said. As part of my ongoing research, Dr. Tulving believes that some people lack the ability to remember personal experiences, and they're otherwise healthy, and I may be one of these people. So I called her, talked to her, and I thought, well, this is quite interesting because she looks in some ways similar to patient ML that I presented to you earlier, but she doesn't have brain damage. So we brought her in, we studied her, and that launched a whole basically line of research on severely, what became to be known as severely deficient episodic memory, autobiographical memory. So here's Susie talking about her memory.
Since then, how would you sum up the difference?
It seems to me that other people have very rich, detailed memories that they can put themselves back into the situation and remember movement and where they were and what they were wearing and the smells that were around them and what they did in sequence, just all very rich. And my memories are always, what I call memories, are always static. They're more like snapshots. Sometimes they're literally memorized photographs. They're always just detailed facts, depending on how elaborate the story is or how many times I've told it to myself or others. There might be more details involved, but it never feels like the memories belong to me. It's always kind of in the third person. And in fact, sometimes in my story, I can see myself in the picture, which of course you wouldn't physically be able to do if you were remembering something from within your outfit.
So around the same time, we were contacted by, started to be contacted by others, just coincidentally. People contacted us separately, and we ended up publishing a case series of 3. Again, this was the work of Daniela Palumbo, who at the time was a grad student in my lab, is now a professor at UBC, University of British Columbia. So 3 healthy middle-aged adults, a physicist, a human resources manager, that's Susie, and a stock manager. The physicist is Nick Watkins. I hope Nick is here. I would refer you to Nick's outstanding article about his own experience that was published in Cortex, I believe. And in any case, all three reported a lifelong syndrome of inability to re-experience past events in the first person, yet their semantic memory and many other aspects of their functioning, pretty much all other aspects of their functioning, were intact. And in fact, their neuropsychological test performance was intact. One exception there was test of visual memory, although even there, I think many people, I won't go into details, I can provide that later if anyone has questions, but even there, we're found in follow-up testing, some patients perform, or not patients, people with SDAM perform normally on that test. So I'm just going to go through some of the results from that research. First of all, we administered the autobiographical interview, which I just presented to you. Now, one thing I didn't tell you is that in this case, we did 1 week, 1 month. So these are going back in time from 1 week ago, 1 month ago, 1 year ago, and so on, all the way back to childhood. The vertical lines here and the yellow triangles represent healthy controls performance, and the three colored triangles here represent three people with SDAM. And in some of these cases, the triangles overlap because they had the lowest minimal ratings. So this chart just shows their own subjective ratings of events that they selected for vividness. So I didn't tell you about this, but in addition to counting the details, we also asked people to rate their vividness. And so all three, as expected, rated their vividness very low, whereas healthy adults, everyone here is healthy, but the control subjects, as expected, rated theirs high because they chose vivid events. This was interesting, though. When we counted up the details, the results weren't as clean. So for recent events, there really wasn't much separation between the people with SDAM and the controls. So these are the number of details you can see here, just like the chart I showed you with HM. Control subjects in this protocol recall about 50, 60 details per event. Some of the SDAM people were low here and there. One was actually quite high for very recent events. It wasn't until the remote events that we started to see these people separate. So this was a kind of a clue that, wait, there's a distinction between these subjective ratings, the vividness, remember the feelings, and the objective ratings, the ability to produce what we would call episodic-like details. So they count as internal details, but they're not experienced as that. And this just shows where we got significant differences through statistical analysis. So the next thing we did is we had them take different events, and we just had them try to relive the events while being scanned with fMRI. And this was an important thing to do because we knew that healthy people, and I keep saying healthy, everyone here is healthy. So control subjects, people who do not have SDAM, activate this canonical set of midline brain regions, including the frontal lobe here, and the precuneus and the posterior cingulate gyrus, as well as the angular gyrus and cerebellum and anterior temporal lobe. So these areas are activated during autobiographical stimulation while thinking about autobiographical events. Very robust, and this just shows for two regions that people with SDAM did not activate as we would expect for someone without SDAM. Now, this was an important thing to do, but it was really confirmatory. If they had activated, if their brains did not correspond with what they were reporting, then we'd have to explain that. So this really just confirms that whatever they're saying in terms of their subjective vividness, it's the brain patterns are corresponding with that. So that was confirmatory. I think the other thing we did is we looked inside the hippocampus. So this is the structure of the hippocampus. The last thing I showed you was the brain function. And in the hippocampal volumes, we did not see huge differences, but we noticed that their right hippocampus was a bit, all three were on the low end of the scale, whereas this was not the case for the left hippocampus. So this is just the raw volume, this amount of brain tissue in the hippocampus. So when we plotted this as a ratio, we found just right minus left. This isn't a ratio, sorry, it's a different score. We found that they were really quite extreme, and in some sense, none of our control subjects had this kind of asymmetry. In fact, and you'll hear more about this in a minute, the normal pattern is that right is greater than left. That's just the way the brain is designed. Now, there's individual variability, but these people are quite outlying on that, and I'll get back to that in a minute. Now, what was interesting, what was more interesting to us is how can they do the things we do? So one of the questions I usually get asked is, how can these people function? They have no memory. And that's not actually the case. They do have memory. They just don't have the subjective aspect of re-experiencing. They can learn, they can perform, they can do things, all the things that are necessary for normal life. And in fact, some things they do even better than normal, which I'll be telling you in a minute. So one of the things they can do is just, if you give them a recognition memory test and you say, was this item presented before? They can more or less do it. So once again, we have these same charts here. Here are 3 subjects with SDAM. A couple are a bit low, one is high, but they're more or less, performing this task. This is a recognition memory task. So these are the kind of tests we like, because if performance is low and the brain looks different, that's confirmatory. But if performance is good and the brain looks different, then we're starting to get at possible either mechanisms or neural correlates of what they're doing. So this particular task is a task where it's used EEG, particularly an event-related potential known as the late positivity component. So this is an electrical recording taken on the back of the brain. And what happens is when you recognize an item at about 400 seconds after, these are tracings, EEG tracings. And for correctly recognized items, you get this late positivity, which is basically the back of the brain. There's lots of activity going on because you're re-experiencing. That's the subjective re-experiencing. And this was completely absent to a very extreme degree in the cases. So this is quite divergent from their performance, which is variable but not grossly impaired. So this, again, clearly, this late positive component is related to the subjective re-experiencing, and it clearly shows this was our first hint that, okay, we really are onto something here with the subjectivity of this. And this is obviously not something you can manipulate consciously. It's something that's recorded from the brain. This is Luis Fuentemilla, who's a scientist in Barcelona. And Luis is an expert on oscillatory dynamics in the brain. And so this is a different way of sort of looking at the same thing. So this is using magnetoencephalography, which is a very sensitive technique to get at brain oscillations, brain waves. And in this particular case, this is a single case study of Susie being stimulated with very rich episodic memory cues, recordings that she had made of events that happened that in someone without SDAM, when you hear these recordings, they evoke a very rich experience. And what Luis found is that when we compared those recordings to just general semantic information, the control subjects showed this massive synchrony in the gamma band. So this is very fast brain rhythms across the cortex. It's basically what we call cortical ignition. That's a term I borrowed from Stanislas Dehaene, who's written a lot about this, although not in memory. The idea that the brain ignites. You get a stimulus, and then I think that the subjective, not just me, many people think that that subjective part may be this very rapid cycling and synchronous gamma oscillations. However, here's what Susie's oscillations look like. And you don't have to do statistics to appreciate the difference between these two images. The next data I'll be describing is from a new sample. So everything I've taught you about is from the 3 cases. We've now tested about 17 people, not counting thousands of people online in our lab. These are just people that we brought in and scanned. And Stephanie Simpson, is a grad student in my lab, has traced the medial temporal lobe subfields that I mentioned before on these people. So we didn't trace the subfields in our original case series because we didn't have the right kind of scans. We just did whole hippocampus. So here we actually have the CA1, DG, dentate gyrus, CA2 and 3, which I mentioned before, and the subiculum. And these are control subjects' brains. So these are fresh data, just partially. We haven't traced everyone's. So this is data in progress. But you can see this right greater than left asymmetry, which is normal across all 3 subfields. So the green lines are individuals, and the black line is the average. Here's what the people with SDAM look like. The first thing I'll direct you to is they have large dentate gyrus CA2-3. That was unexpected. I'll get to that in a minute. But the other thing we find is that look at the look at this line, the slope of this line. It's opposite to the controls. So once again, it really replicates this thing that I just told you about before. This they don't have the expected asymmetry, whereas healthy controls. I keep saying healthy. I got to stop saying that. Everyone's healthy. Control subjects have larger right than left, and and that's true for everyone. It's very robust and reliable, and it's true not just in our sample. It's true in general. People with SDAM don't. They have a very large left subfields, the right as well. Both are enlarged, but in particular, the left is enlarged. So next, I'm going to show you data from the Fornix. So I mentioned the Fornix earlier. It's a large white matter tract that carries information from the medial temporal lobes to the rest of the brain. It's coming out. It's the main outflow of the hippocampus. So I just told you that their subfields are large, but that's not the case for the Fornix. So this is actually 17 people that we've done tractography on their white matter tracts. This is the only tract where we're seeing a difference, and it's exactly as you would expect. The Fornix is small, and it has lower integrity compared to controls in the SDAM versus controls. So as I mentioned, the Fornix carries information out of the hippocampus to the rest of the brain. So even if you have an intact or even larger medial temporal lobe, for some reason, if there's a disconnection, that information is not being carried out to the rest of the brain. Now, what are the functional implications of that? This is where we get to a study run by my colleagues, Brad Buxbaum is a scientist, and his grad student, a scientist at Rotman Research Institute with me, and his grad student, Michael Bone. This is an imagery paradigm, but it's also a memory paradigm. And after all, images are memory. They're drawn up from memory. So I'm sure that this will come up in the questions, but the distinction, I think, is more of a semantic one. In any case, in this paradigm, people see these images in a serial, like 30 images like this. So this is just examples, as well as the word. So they see this, they see the word roller coaster, then a second or two elapses, and they see this, etc. After some period of time has elapsed seeing these, they then have a retrieval task where they just get the word and they have to imagine the picture. Then they have to rate how vivid their image is, and then they have to say, is this old or new? Now, in this case, it's new because, as you can see, this roller coaster is slightly different from that roller coaster. So it's a quite challenging task to do that. So what Brad and Michael have done is quite sophisticated, is they've used deep convolutional networks to get at various aspects of the brain correlates of experience. And I don't have time to go into detail. I can see I'm running out of time, but there's low, mid, and high level visual features and semantic features. So the low visual features really relate to the lines, the angles, and things. The mid-level features relate to a more complex visual material, and the high-level features will relate to things that are more like images, as you can see here. And these are actually can be decoded from the brain. And this just shows you the brain areas and this is all separate work that's done by Brad and Michael based on this deep convolutional neural network theory. So the semantic, the highest level, is just ideas, thoughts, abstract thoughts, and those occur in different areas of the brain. So this was a great paradigm for us to try in our sample. Again, these are data in progress, but what we find is whereas control subjects engage the low-level features during that imagining part of the experiment, where you're just looking at the gray box, the people with SDAM don't. They, in fact, engage, in this particular analysis, it looks like the semantic is a bit lower. But in other analyses, we're finding that there's a difference in the low-level features, but the high-level semantic features are intact, which really, I think, meshes well with what we've heard in all the talks so far, as well as what our patients, our people with SDAM tell us, which is basically they're not accessing low-level phenomenology in their conscious experience. They're accessing things at the conceptual level. So I'm just going to summarize everything I've said so far. So the hippocampus is involved in the binding of details, this cue-driven detailed generation of details where the what, where, when of events. And this may be intact or even enhanced in people with SDAM. The Fornix sends that information out to the rest of the brain. That may be impaired. And what you might expect then, remember the feelings. This is key. That's what we're talking about, the subjective experience. That's the cortical ignition, and that's what's lacking. Now, one theory might be that it's due to disconnection here. That's just a theory. These are very early days, but I'm just putting it out there, hoping to get people's feedback on that. So I'm just going to zip through some very quick data here before I stop. Maybe Tom or Fiona could just type in the chat how much time I have before we have to take questions. But based on this work, we were interested. Oh, that's perfect. That 10 minutes is an eternity. That's like years. So, and does that include questions? Because I want to make sure we have time for questions. And I know there's a panel, so there'll be more time for questions. Okay, great, perfect. So I can relax a bit. So this is Daniela, based on the work in SDAM in our lab, Daniela Palumbo, and I, with some other colleagues, particularly Hervé Abdi at UT Dallas, a mathematical psychologist, developed this test called the Survey of Autobiographical Memory. So the idea behind this is, okay, we figured out something with SDAM. We have a lot more to do. So not to say we've solved that problem, but now we want to go into everyone else, the normal spectrum. Someone asked earlier about what is the incidence of aphantasia. A very easy way to answer that is just through statistics. If you have a distribution, if you assume there's a normal distribution of people with imagery, then you can just statistically say people at the lower 2% have aphantasia. They're different enough. That's 2 standard deviations. They're different enough from everyone else to say that they are qualitatively different. Now that's an arbitrary line, but let's just, for our purposes, I think that's a useful kind of assumption, and I think it fits if you look at other neurodevelopmental disorders, dyslexia, synesthesia, and so on. They probably occur at the same level, merely because when we measure them, we have to define a cutoff somehow, and that convenient cutoff is 2%. Anyway, here's our test that we've developed to get at this. So it's called the Survey of Autobiographical Memory. Again, bad title. Also, SDAM is a bad title. I wish I had access to a Greek scholar or a linguist to come up with a better name, but that's the name we had. So the Survey of Autobiographical Memory isn't just about autobiographical memory. It's also about, it's into these 4 subcategories: episodic memory. When I remember events, I can recall people, what they look like, etc. Semantic memory, this is factual memory. Spatial, this is navigation, and future is imagining events that could happen in the future. So our initial study of this, which was done by Daniela, was with about 400 or 500 people, getting the factor structure well. Once Susie went public with her SDAM, and there started to be a lot of media attention on the BBC and CBC and here in Wired, we started to get many people contacting us. We've actually have now 30,000 records of people. Those aren't all high quality, but 30,000 people that have come to our surveys to contact us. And this would be a good point to mention that our survey link is in the research links on the research part of this conference. So Karina Fan is a grad student in my laboratory, analyzed those data and basically replicated the factor structure of the SAM. It's very robust. We actually have about 15 samples now, and it just holds in every single sample that we've done. So we're quite confident in this factor structure, which just delineates which questions relate to which aspects of memory in the constructs behind this instrument, again, separating episodic, semantic, spatial, and future. So we're particularly obviously interested in this episodic subscale, which gets at the kind of the re-experiencing part of autobiographical memory. The reason we wanted an instrument like this is because we wanted to look at traits. So everything I've told you up until now is really about tests. It's about bringing someone in and testing them on a single occasion, asking them to describe events or doing things in the scanner. This instrument now allows us to answer questions about what are you like in general. So anyone, even patient HM, can recall an event, as I showed you earlier. But for the purposes of the questions we're asking here, we're asking how are you in general, not how do you do on one specific instance of a test. So the first thing, one of the first things we do with the SAM, this was Sidney Sheldon, is a former postdoc in my lab, now a professor at McGill, is we looked at resting state functional connectivity. And in this particular study, we asked, we gave people the SAM outside of the scanner weeks before the scan, Then they came in, they did a bunch of stuff, including a resting state functional connectivity scan, which gives us a sense of the basically functional architecture of the brain. And in this particular study, we're asking, how does the hippocampus, which is involved in memory, connect or correlate, activity in the hippocampus correlate with other areas in the brain at rest. Why at rest? Well, because when you're at rest, what are you doing? You're thinking, you're doing spontaneous mental thought, and that's what we're interested in here. So people have been in a scanner at rest, they know, or I mean, frankly, sitting in a chair at rest is the same thing. Your mind starts to go to the past, it goes to the future, it thinks about things that you've done or things that you're about to do. So in this particular study, what we found is that people with high episodic memory, as endorsed by the SDAM, tended to co-activate the back of the brain involved in visual processing with the hippocampus, whereas people whose semantic abilities self-rated on the SAM exceeded episodic abilities activated the front of the brain in concert with the hippocampus. So what does this mean? If you're someone who tends to excel at semantic, factual, implicational, or schematic thinking, when you're in the scanner, now this is functional kind of inferences based on the scan, so we have to be cautious with this, but we know from other studies that you're probably connecting memories up to plans, to futures, to schemes, things that you might be doing, or to strategies. Whereas if you're someone who tends to have richly episodic memory, at rest, you're actually seeing things. And that's what this study shows, which is very much consistent with what Adam showed this morning in Aphantasia. Another way to look at imagery is with oculomotor function. And this is quite unique. This is work done with Jen Ryan, who's a scientist with me at Baycrest, who studies eye tracking, and Mike Armstrong, who was a grad student in my lab at the time, conducted this study. So in this study, what we did is we sent people on a tour of Baycrest, and then 2 days later, we had them sit in a chair and just recall the tour verbally, but we tracked their eye movements. And we had people with we had people across the range of the episodic autobiographical memory as measured by the SAM. For convenience here, we split them into high and low, but this is really a continuous measure. And we looked at the autobiographical internal details, and we found that, as expected, the number of details that you recall is related to how vivid your episodic memory is at a trait level. So now we're bringing together an event with the trait, and we say, okay, you're someone who endorses high episodic memory in the SAM, you traffic in images, and you're actually moving your eyes more when you're recalling this episode, a controlled event. People with low episodic memory, they traffic in thoughts. I shouldn't say thoughts, abstract schemas or implicational processes, not images, and they actually don't show this correlation. This isn't just a correlation positive in one and negative or absent in another. It's actually statistically significant interaction. So this suggests, and Adam, this is all very similar to Adam's slide that he put up. This wasn't one of the slides I was doctoring before the talk that you saw me messing around with. I actually wrote this last night or a few days ago. In any case, this suggests there are two ways of mental access to the past. The vivid episodic re-experiencing, which is highly perceptual. It's involved in pattern reinstatement, and this cortical ignition and subjective sense of mental time travel, versus implicational or non-episodic memory, where you can generate these internal details, but they're not experienced the same way. It's a phenomenological difference, it's acontextual, and it's lacking in subjective recollection. So I'm going to finish off with some work done by my current postdoc, Mariah Sokolowski, in my lab, and this is working with occupation. So Adam already presented data, which basically what I'm going to show you, bottom line, is the same as what Adam said, but it's coming at it through memory. And we use the ONET database, which I believe Adam did in his study as well. What was cool, though, very sophisticated in Mariah's work, and this is with Hervé Abdi and his student Ruchi in UT Dallas, is we took the ONET data. So this is what the ONET is. It's a U.S. government database of occupation, and you can look up any occupation here and get a bunch of ratings, for any possible characteristic. And there's a ton of information here. This is just a sample of what you can get. What Mariah did with Hervé and his students in his group at UT Dallas was basically create, through multivariate statistics, a multidimensional space where you can put any occupation in and get a score. And so you're not dealing with these categories. You're actually dealing now with a continuous measure. So this is just an example. There are two components in this multidimensional space. Component one separates basically the engineers from the humanity types. Component two, in this case, separates the analytical mathematical types from the healthcare practitioners. So this is a very coarse, I obviously don't have time to go into this in detail, but this is a very coarse way. So the point is, you can take any job in this space and extract a score on this component. So you're throwing out the job title and you're asking, okay, how mathy is a job? How much does this job deal with the humanities? And so we're not dealing with these discrete titles anymore. We're now dealing with the score, much like you would have a test score. And this is very preliminary data, just based on some work that we've done. We found that this is the SAM episodic subscale, and this is dimension. This was the slide I was trying to fix before the talk to get better labels on the slide. And so this is the dimension that relates to how mathy are you versus humanities. So the higher you are on this scale, the more mathy you are, and the lower you are, the more semantic are, based on your occupation. And this just shows that mathematics, or STEM, if you will, science, technology, engineering, and so on, is negatively correlated with your endorsement of episodic memory on the SAM. And this is exactly the same as what Adam showed using a continuous measure. So this again suggests that the way people reason and think in these conditions may actually confer advantages. In this case, the more the worse, if you will, your episodic autobiographical memory is, the more likely you are to excel at these kind of math and STEM professions. Finally, I'll just mention this great work by Karina. This gets at the aging implications of this. So one hypothesis might be that if you are have low episodic memory, that as you age, you're going to have more problems. So the vertical, this is our fake data. This is just modeling to show you a hypothesis. So the idea here, if symptoms is on the vertical scale here and age is on the horizontal scale, as you age, if you're someone with low memory, you might be, well, my memory's bad. I'm going to have more symptoms as I age. Whereas if you're high, you're like, hey, I'm a big, strong memory person. I'm going to remain stable with age. So that's one hypothesis, and that's sort of I think the intuitive hypothesis. But we actually tested an alternative hypothesis, which is basically, if you will, kind of in coarse language, say high episodic memory is bad for age. So in other words, the prediction here is that if you have low episodic memory congenitally, you're born. So at age 50, you're coming into your middle age and aging period as having congenitally low episodic memory. You won't care. When your medial temporal lobe suffers from age-related changes, which is normal, or possibly incipient Alzheimer's, it's not going to affect you as much. Why? Because you've already developed compensation. You've already figured out how to get by without episodic memory. Whereas, remember, the high episodic memory people, they traffic in memories, they traffic in details, and they traffic in images. That's relying on the medial temporal lobe, and it's connected out to the rest of the brain. They might have an increase as they age. Now, I can tell you personally, I'm around here. I've noticed changes in my memory, but my episodic memory, it's not terrible, it's not great. I've already developed some compensations, and I know people in my family or my friends who have really good memory, and they just, it drives them nuts because of their aging, and they're like, wait, what's happening? I can't do the stuff I used to be able to do. In any case, long story short, what we found is support for this hypothesis. These are real data in 1,000 people that we tested online, showing that with age, with advancing age, people with low episodic memory endorse fewer symptoms with advancing age, whereas people with generally high episodic memory actually report slightly increasing symptoms with age. So it's not exactly the same as predicted here, but it's close. So I'm just going to conclude, sum up, and say positive note about deficient memory, or if you will, aphantasia, and we can talk about the relationship between those two things. We think they're better able to extract generalities across disparate instances. They may have an affinity towards tasks or careers emphasizing conceptual processes, such as software design, STEM, and so on. This is gender. I don't have time to get into this, but I think there are gender implications from this, and I'm happy to answer those questions later. And then there's maybe resilience to age-related decline in people with lower episodic memory abilities congenitally. And finally, don't average across people with different trait memory capacities, because you might just end up with noise. So I'll stop there.